Hi, welcome, Isaac.
Thank you.
All right.
Yeah, my name is Kuma Yeboah, and I want to share my screen now. I don't know whether it's visible.
Not okay. It's coming. It's coming. All right,
Okay,
it's there.
sure. Thank you so much for this opportunity. I'm
All
presenting on power harvesting system using embedded Piezo-Pack power supply to charge mobile phone. And my name is Kuma Yeboah, currently the head of International Digital Center of Pentecost University. The aim of this research work is to see how best we can harvest ambient vibration in our environment to actually convert them into electrical power and use it to charge handheld devices. Now, we were able to achieve this particular device by using Texas Instruments components, which we actually built our own EPPSS device using electronic components, and we back it up with the Texas Instruments components to actually boost the power or the current output of the device. When the device was designed, we tested it on two main systems, that is on keyboards and then also on keypads of mobile phones. And it came out that with the keyboards, we have 7.5 volts, and then with the keypads on mobile phone, we have 3.3 volts. Now, moving on to the introduction aspect of the whole work, as can be seen over there on a slide, power harvesting systems has become very important of late because of the IoT, that is Internet of Things, that are coming into being. And also we need smart devices, and power will be one of the vital component or sources that will drive all these systems. What about if we find ourselves in a situation whereby there is no power source and our devices are to be able to power themselves or generate energy that can power the handheld devices? It will be a cool stuff. So that is what this research actually aimed at achieving. And we were motivated by the work of S.R. Anton and H.A. Sonadon paper, which is titled A Review of Power Harvesting Using Piezoelectric Materials, which can be found in the Journal of Smart Materials and Structures, Volume 16, 2017. And they confirmed the comprehensive research that has been done in piezoelectric devices. And actually what came out was that they gave so many future application of these devices. But what my team realized was that they have not considered one of the most important things, that is handheld devices. And the next slide, which comes, shows the various areas that they actually indicated that can be piezoelectric materials can be applied on in the near future. That is the hearing aid of deaf people, smart screens or touch screens that we all know. Also, putting it in our fabrics to actually see the stress and strains that are taking place in there. And then also on bone marrows, where we have people who have osteoporosis, where they can actually detect the amount of stress that are placed on the bones and how best it can be converted. And all these things was being designed or was designed using zinc oxide nanowire thin film material. And as the device deforms, the voltage that comes out is measured on a voltmeter. So we picked this clue and we realized that, okay, this thing can also be applied to handheld devices, especially devices which have key depressions. So that is what led to this actually research work, as can be seen. So this is the design stage of our EPPSS systems. We actually pick a piezo transducer, And then from there, we design a power doubler system, which can actually improve the electrical or the voltages that the micro voltages that are harvested from the piezo material, so that it can reach the requirement of the handheld device that we apply them on. We actually use Texas Instruments device TPS 54231 EVM, which was able to step up the micro voltages to 3.3 volts. And then the TPS 640 EVM 178, whose output was then used to charge the mobile phone. And also, due to the key depression on the laptop keys, we were able to harvest energy which was up to 3.7 volts. The next slide shows the block diagram of our design. We have the piezo transducer, which, based upon key depression, will deform the internal dipoles inside the piezo material to align in one direction, and a voltage will come out, which will enter into the voltage doubler, which was designed, which will amplify the voltage, and then henceforth send it forth to the TPS 5420 EVM, which then also amplifies it and supply it to the TPS 6400 EVM, which also then smoothing it and then send it to the output load that is needed. And here we are talking about the mobile phone. The next shows a circuit diagram of the whole system, which shows the piezo material, which is inside. That's the circuit diagram. The circuit diagram, which has a piezo crystal and 4 network of a bridge rectifier diode, which is performing rectification from AC to DC. And then it supplies to 2 capacitors, which then stores the output voltage and then supplies it to a transistor, which amplifies it. And then we have 1 diode there, which prevents drawback voltage. Hence, it is tapped into the EPPSS, that is the Texas Instruments devices, and they then supply it to the handheld device. The next shows the graphical plot of the depression in terms of this depression was measured in newtons. So we have 10 newtons indicated in blue, 20 newtons indicated in red, and then yellow indicating 30 Newton pressure that is placed on the keyboards. And we can analyze it in terms of the surface area where the depression took place. And the EPPSS gives us the efficiency of current which is generated, and as can be seen over there in the second graphical plots, how the voltage, the currents were generated from the EPPSS Piezo-Pack systems, and as can be seen over there. The next slide gives further explanation of the output voltages. The efficiency of the TPS 54233 EV pack at a load current of approximately 0.1 amp at 45% efficiency was received, and then increased exponentially to a current of 0.5 amps at an efficiency of 72.5%, as can be seen over there. And then output, which was gained from that system, was 3.3 volts. And the figures down there shows when the EPPSS was being tested without the Texas instrument. And then as can be seen, we can see 22.97 volts being measured on a multimeter. And then later on, it was connected to the Texas Instruments devices while the key depression was taking place. And we can see 2 dry cells, which was connected to the EPPSS device to power a crystal, which was on board the EPPSS device. So that is the function of the 2 batteries, dry cells that you can see over there, because that will determine the amount of voltages that should be supplied to the power section of the mobile phone, so that it doesn't give excess voltages to the battery. Otherwise, the mobile phone battery will damage. So that is the essence of the 2 dry cells that can be seen over there. While the key depression, the piezo sensor
You have a
was
minute.
placed.
You have a minute left.
Okay, very soon I'll be done. Thank you so much. So the next slide shows the Piezo-Pack, which has been connected to a mobile phone, and the battery is being charged as the key depression takes place. The energy has been stored in the capacitors, and they then supply it to the mobile phone for charging. So in conclusion, the aim of the research was achieved based upon the voltage that came out from the Piezo-Pack system, which was 3.3 volts, and it was able to power and charge the mobile phone to its maximum capacity. And this device can actually be applied to any handheld devices like mobile phones, TV, remote controls, and any handheld devices. And it will be actually helpful to any systems of that nature. Thank you so much for this opportunity. And any question is actually available. I'm available to answer any question from the participants. Thank you.
Thank you very much. You'll check the questions if they have any on the Q&A tab. So just keep on checking them there, and then yeah. Thank you very much.